A warm welcome to everyone to today's webinar on a multi-pronged approach towards small modular reactor regulation. The moderator for today's session is Ms. Denise Cheong, Head of Nuclear Law and Policy at the Center for International Law, or CIL, at NUS. Without further ado, we begin the webinar now. I hand over the floor to Ms. Cheong to begin by providing the opening remarks.
A very warm welcome, everyone, and thank you so much for joining us today. As part of my opening remarks, I would like to briefly cover three areas. First, introduce the work we do as part of the Nuclear Law and Policy Focus Area at the Center for International Law. Second, touch on the ASEAN context that is relevant to our seminar topic today. And then third, provide a bit of background and set the objectives for today's webinar. So nuclear law and policy is a relatively new focus area for our center. Since 2016, we have been carrying out legal and policy-oriented research related to the use of civilian nuclear energy, principally focusing on nuclear safety, security, and civil liability for nuclear damage. At CIL, our focus is on the study of legal and institutional frameworks at both the international and ASEAN levels, including how these frameworks relate to one another. At the ASEAN level, our research work is focused on understanding the normative and institutional framework that applies to the governance of nuclear power. This has involved and continues to involve a documentary analysis of the relevant ASEAN instruments and the mapping of the associated governance framework. Of particular interest to us are cross-sectorial legal and policy issues, such as our ongoing research on marine-based SMRs, work that cuts across the nuclear, marine, and environmental sectors. In terms of the ASEAN context that is relevant to our seminar topic today, I would highlight the following. First, within Southeast Asia, while none have made the decision to deploy nuclear power, several ASEAN member states have plans and are taking steps towards possibly developing nuclear capacity over the longer term, where SMR deployment is a potential option. Second, in the latest release of the ASEAN Plan of Action for Energy Cooperation for the next 5 years, or APAE Phase 2 for short, the building of capabilities in emerging nuclear technologies such as SMR technology and capabilities in legal and regulatory frameworks, including licensing, are strategic and/or priority areas for its program on civilian nuclear energy, sometimes referred to as Program Number 7. The NECSSN, the full name's on the slide, is a specialized body that is forging ASEAN-wide cooperation for this program. Third, as ASEAN contemplates the possibility of nuclear power deployment within the region, it is important to remember that as a region, ASEAN has made a commitment early on to follow international rules, standards, and practices in the area of nuclear safety. So from an ASEAN perspective, developments related to international rules, standards, and practices applicable to the safe regulation of SMRs would be of relevance to the region. In this regard, ASEAN-TOM, ASEAN's network of regulatory bodies, plays an important role in enhancing regulatory activities as well as fostering cooperation with key external partners such as the International Atomic Energy Agency, the IAEA. Both ASEAN-TOM and the NECSSN help to realize this important commitment through activities including the sharing of experiences and best practices, as well as training and capacity building activities. I shall now proceed to introduce today's webinar. At present, there are a large number of SMR concepts under development, covering a wide range of technology approaches and maturity levels. Configurations include single unit installations, multi-module plants, as well as mobile or transportable units. In general, due to the reduced size of SMRs as compared to traditional large reactors, key design features of SMRs are such that they are said to offer the promise of enhanced safety, improved security, and flexibility in terms of where they may be located and also what they can produce beyond traditional baseload electricity generation. Given their small and modular nature, SMRs are said to have the potential to change the business case for nuclear power. For example, through lower upfront capital, shorter construction times, the option to scale as needed in the case of multi-unit SMRs. In short, reducing the overall investment and capital risk. However, for SMRs to be economically viable, this business case must translate into a global market for SMRs. To date, the outlook for such a global market remains uncertain. The COVID-19 pandemic has intensified calls to accelerate the clean energy transition, where energy systems are facing pressure to decarbonize and where low carbon energy options, including SMRs, will need to compete for opportunities within the fast evolving energy landscape. So assuming there is market demand, assuming there's supply chain maturity, as well as the ability to finance, regulation remains yet another key challenge. The challenge facing the licensing and regulation of SMRs arises from the cross-border nature of future commercial deployment. SMRs could be designed, manufactured, and operated in different countries, each with their own national regulatory approaches. So key questions that arise include, in light of these different national approaches, what is required for effective and efficient licensing and regulation? And is there scope to streamline and harmonize licensing and regulation? And if so, how would we do it? What is clear, however, is that effective licensing and regulation of this global enterprise will require international collaboration and cooperation by both industry and regulatory bodies. So it is with this context in mind that we will explore today the collaborative activities and initiatives that are being fostered through the Small Modular Reactor Regulators Forum, as well as at the industry level, looking at the licensing model study undertaken by Fermi Energa in Estonia and the Baraka licensing and regulatory experience in the UAE. So turning now to our panelists, we're very privileged to have with us today 4 panelists. Allow me to briefly introduce them to you. The full bios can be found on CIL's website. First, Mr. Miguel Santini, Senior Nuclear Safety Officer of the Regulatory Activities Section of the Division of Nuclear Installation Safety at the Iaea. Miguel's main responsibility is the coordination of integrated regulatory review service missions, but he is also responsible for all SMR regulatory work and is the scientific secretary of the SMR Regulators Forum. Miguel has also worked in the Canadian Nuclear Safety Commission for 25 years in various senior positions. Our next speaker is Ms. Camille Scotto de Cesar, Legal Officer of the Office of Legal Affairs at the Iaea. Camille's main responsibilities include providing legal inputs to the Division of Nuclear Security and the SMR Regulators Forum. Prior to this, she worked as an Associate Safety Officer in the Regulatory Activities section and was also part of the Secretariat of the SMR Regulators Forum. Third, we have Ms. Helen Cook, legal partner of Fermi Energa and principal of GNE Advisory. Helen has advised on many major nuclear projects around the world, representing a range of different actors. She has also served as legal expert on multiple IAEA missions and is the author of a comprehensive legal textbook entitled The Law of Nuclear Energy. Finally, we have Mr. Ian Grant, Advisory Board Member of Fermi Energa and Principal of Ian Grant Consulting. Ian held a senior leadership role with the Federal Authority for Nuclear Regulation, or FANA for short, in the UAE, where he helped to establish FANA and oversee the construction and commissioning of their first nuclear power plant. Ian has also worked at the Canadian Nuclear Safety Commission, where he was responsible for safety assessment and licensing of nuclear power plants. Before I turn to our first presentation, I would like to remind our audience that they are very welcome to ask questions through the Q&A function, and these will be answered after all panelists have presented. So for our first presentation today, this will be a joint presentation by Miguel and Camille. Miguel, the floor is yours.
Thank you, Denise. Good morning, afternoon, and evening to everybody. It is a pleasure for us, representing the Iaea, to take part of this webinar. As Denise mentioned, this is a joint presentation. My name is Miguel Santini, and I will do the first part, focusing mainly on the technical aspects of the regulation of SMRs. My colleague Camille Scotto de Cesar will do the second part of our presentation with focus on the legal challenges of regulating SMRs. To ensure we are all on the same page, we will start with the way we at the Iaea define SMRs. The definition is widely used by the Iaea departments in their multiple activities, and it is also used by the SMR Regulators Forum, which I will describe later in the presentation. The salient features of the definition is first the power limit. Although they are considered nuclear power plants, they ought to be of much lower power than the conventional MPPs, with a much smaller footprint, and must be used for commercial purposes for generation of electricity or cogeneration for other uses, such as desalination, process heat, etc. It is important to exclude research or test reactors from the group. The SMRs must be designed in a modular fashion as a unit or ensemble of modules for a unit. The units might be located in close proximity and perhaps share some infrastructure. They may use novel design features such as passive safety system, also known as inherently safe systems, to minimize the likelihood of accidents, or should they occur, minimize the consequences of this on the surrounding areas. No reference in the definition to the place of deployment is made, hence SMR could be land or marine based. Next, please. The SMR Regulators Forum perhaps is one of the most all-encompassing initiatives of the agency on SMR regulation. What is the forum? The forum is a regulator-to-regulator group with 10 participant countries shown on the screen, and external observers invited on a permanent or as-needed basis, such as the case of Cordell of the World Nuclear Association. The Iaea plays the role of scientific secretary of the forum. And what does it do, or how does it work? So the government is governed by the terms of reference drafted by the members, which defines purpose, objectives, guiding principles, membership, technical contributions, etc. The Annex A of the forum, of the terms of reference, defines the technical topics of work by phase. These terms of reference can be found on the forum page, on the Iaea webpage. The forum is led by a steering committee and features technical specific working groups which will implement the specific portion of the project plan and report progress to the steering committee and produce the reports. Next slide, please. The main objectives of the forum is to share regulatory experience among its members and to discuss safety issues and the challenges faced by the members in regulating SMRs. The members strive to reach common positions on those challenges and potential solutions. The forum also plays an important role for the agency in advising on potential improvements to safety standards, to make them useful to SMR design to support all member states. Next slide, please. The forum produces reports accessible to all member states to share the products of the discussions. The reports mainly state position statements on regulatory, policy, or technical issues by the members and make recommendations for revisions of or drafting of IEA documents, especially on potential enhancements to the IEA safety standards with respect to SMRs. Next slide, please. This is a very concise summary of the areas of technical work tackled by the forum since its creation in 2015. In the two initial phases of the forum, the members selected topics of work that were, in their views, the most pressing matters for regulators in regards to SMR. The focus of the discussions was centered on the difference with respect to regulating conventional nuclear power plants, and this includes footprint, proposed deployment models, advanced and novel design features, and impact on emergency planning. The list of topics is on the slide, and the reports for these two phases can be found on the forum page on the agency website. Phase 3 was started just this year. Next slide, please. The slide shows the main topics for Phase 3. The focus of work of the forum shifted to collaboration among regulators for the regulation of SMR, considering the complex interaction and export schemes currently proposed by vendors, with the introduction of multiple new players with limited experience in the nuclear field and operators with limited or no experience in nuclear power plants, such as the embarking countries. As an example, it is expected that the number of manufacturers of SMR components may grow exponentially and be distributed all around the globe. There is international consensus that the regulatory oversight must be exercised by the regulator in the recipient country in an independent way. The regulatory body of the recipient country may need to find the mechanisms to exercise its oversight over multiple jurisdictions, adding complexity to its regulatory functions, such as inspections. The possibility of transportable SMRs, which may feature factory fueling or commissioning, makes the regulatory functions even more complex, encompassing potential legal conflicts and constraints. Camille will address this in the second part of the presentation. Next slide, please. The forum has requested the Secretariat to promote the work of the forum to other member states. The Iaea is doing this through the implementation of regional workshops, whereby the forum members will present the outputs of the technical working groups, discussions on common positions. We are planning the quarterly workshops shown on the slides. For East Asia and Australia, this will probably take place in Q3 or Q4 in 2022. The cost country for this workshop is yet to be determined. Next slide, please. Now I will briefly turn my attention to the IEA most relevant work on SMR regulations. Next slide, please. The slide shows perhaps the most important initiative the agency today on the regulation of SMR. The intent is to determine in regards to the various proposed MPP were developed mostly for water-cooled land-based reactors. This will be the results of this initiative will be presented in the format of a safety report, which will document the main gaps of the present standards and provide the basis for the development of a prioritized program of work to address the gaps in the areas of non-applicability. We expect to publish this safety report by the end of 2021. Next slide, please. Another important initiative on the regulation of SMR is the documentation of the experience gained by some member states in the regulation of SMRs or in the process of preparing to regulate them. The information was gathered through extensive questionnaires submitted and completed by relevant member states, which had that experience. And we expect to release this information in the format of a tech talk also before the end of 2021. Next slide, please. I will now transfer the floor to my colleague Camille, who will talk about potential legal challenges. Camille.
Thank you, Miguel. So considering Miguel's presentation of technical specificities of SMRs and the particularities of the deployment models they could trigger, potential legal challenges appear in two different spheres. First, there are questions about the applicability and the adequacy of the current international nuclear legal framework and its compatibility with other international legal frameworks. Second, there are national challenges associated with the deployment models. Those challenges will be addressed within the agency in different fora, taking different approaches, mainly under the SMRs Regulators Forum with the licensing working group, the consultancy meetings mentioned by Miguel also, or other consultancy meetings. If we go now in more details concerning the challenges I just mentioned, we start with the international legal framework. And here we have to raise different questions. First, are the international instruments applicable to SMRs? And this includes Iaea safety standards and security guidance. In most cases, it seems that the instruments could apply to SMRs, or at least the majority of them could. However, even if the instrument may apply, it should be recognized that they were not developed with such reactors in mind. The provisions are not specifically adapted to this technology. Therefore, a question arises as to whether the frameworks are adequate, considering design and technical features and unique deployment scenarios. Finally, the question of compatibility between the different international legal frameworks also need to be raised. And here I'm referring specifically to the law of the sea and maritime law. So let's take some examples regarding the international legal framework governing the peaceful use of nuclear energy. I want you to take multiple examples, but in 10 minutes it's very short. So I will start with civil liability for nuclear damages. In civil liability, the International Expert Group on Nuclear Liability, INLEX, had the chance to review the definition contained in the conventions to see whether they are applicable to SMRs and potential issues are related to floating NPP. The group considered that a transportable nuclear power plant in a fixed position would fall under the definition of nuclear installation and would therefore be covered by the nuclear liability regime. The group also considered that the transport of a factory-fueled reactor would also be covered by the nuclear liability conventions, just as any other transport of nuclear material. However, such conclusion could not be applied in circumstances where the reactors was used for the propulsion of the vessel. During the movement of the vessel, it would fall outside the definition of nuclear installation contained in all conventions. Those main conclusions were reported to the Iaea Board of Governors through the Nuclear Safety Report. Another issue arises where the deployment of such a reactor involves states not party to the same Nuclear Liability Convention, and they gave the interpretation as to when the transport of liability from one operator to other should happen. It clearly demonstrates that even if the convention could apply, they may not be adequate because the deployment scenario of some SMRs design were not considered. I will take the example of the Convention on Nuclear Safety in the domain of nuclear safety. So we will consider for the applicability of this convention. At first glance, we would say that the CNS as applicable to nuclear installation will cover SMRs, even though they are small and modular in nature. But there is a specific definition of nuclear installation, and the CNS applies only to land-based civil nuclear power plants. Here again, the issue arises concerning floating nuclear power plants, and is still unresolved because it is up to the contracting parties to determine whether such definition could encompass floating NPP. In April 2011, at the 5th review meeting of the CNS, which was held right after the Fukushima Daiichi nuclear power plant accident, the contracting parties decided to organize an extraordinary meeting which established a working group on effectiveness and transparency. Extending the scope of the Convention to include other types of reactors, specifically research reactors and transportable ones, was identified as one of the areas for consideration by the working group. Multiple solutions were envisaged, such as amending the Convention, making an authoritative interpretation of the definition of nuclear installation to include transportable reactors. Overall, there was not much support for the two first solutions, and some participants claim that transportable NPPs are not yet established and that the question should be dealt with when plans to operate such NPPs become more concrete. We were in 2013. However, following the proposal of the Working Group on Effectiveness and Transparency, amendments to the guidance document were adopted and a new paragraph was added to the guidance document encouraging contracting parties to report on a voluntary basis on the safety of other types of civilian nuclear reactors. Now, is the CNS adequate? We have to note that it's written in general terms, and the obligations such as having a legislative and regulatory framework in place, a regulatory body giving prime responsibility for safety to the license holder, to give priority to safety and emergency preparedness are also valid for small modular reactors. Unfortunately, I have no time to go into the details of the transport reg, but questions concerning their applicability and adequacy do arise and need to be considered in parallel with the instruments adopted under the auspices of the IMO, the International Maritime Organization. Indeed, these regulations have been incorporated into the UN recommendation on the transport of dangerous goods model regulation as Class 7, which in turn is incorporated into the IMO International Maritime Dangerous Goods Code, which is made mandatory through Chapter 7 of the 1974 International Convention for the Safety of Life at Seas. And pursuant to Article 23 of the United Nations Convention on the Law of the Sea, a ship carrying nuclear materials through the territorial sea is required to observe precautionary measures stipulated in so-called international agreements. The 1974 SOLAS Convention and its Chapter 7 governing the carriage of dangerous goods and applying IMDG codes is certainly one of those international agreements. Plus, we could also note that from an IMO perspective, if transport regs are found not to be adequate, it could reignite the debate concerning fundamental principle of territorial sovereignty of a coastal state and the freedom of the seas by a flag state. Thus, the two regimes are intertwined. If we go now into the national legal framework, we will focus on some characteristics of the deployment of SMRs relevant for the regulator point of view. Let's take the example of an SMR partly built in manufactories, factory fuel, and then transported on-site, when the manufacturing site is in one country and the construction site in another. The small modular reactors will possibly be already constructed, at least partially, before the license in the host country is issued or even applied for. The regulatory process during the first stages of the lifetime of the facility may have been completed according to the regulatory process in the fabricating country under oversight by its own regulatory body. In this context, the following question arose. How can regulatory function, authorization, review assessment, inspection, enforcement be performed by the host regulator? With this deployment model in mind, we would raise the following points. First, a country might need to revise its licensing steps, sometimes detailed in their nuclear legislation, that could potentially not fit such deployment scenario. Second, we can note that when part of a nuclear power plant is manufactured outside the country, it is a practice for the regulator to be able to perform its functions, such as pre-licensing, construction inspection on site, through the licensee. But if reactors are built in factory before the licensee has been identified, how to perform such function? How can multiple regulators then work together to ensure oversight? Would it be possible to share regulatory responsibilities? A sub-potential risk, which is equally true for any NPP, but maybe more crucial considering the deployment scenario, is the potential political and economic pressure on a regulator to accept a design which raises the question of regulatory readiness and independence. Knowing that SMRs are particularly attractive to small embarking countries. Third, access to manufacturing sites is possible for components or even safety critical system, but access to the entire chain of production of a reactor raises the question of industrial property and to what extent sharing of information may be possible. Fourth and final, noting that vendors will achieve economy of scale by producing in series, they won't be able to adapt to each country's regulatory requirements. It may not be a problem for standardized components. However, at a higher level of requirements, such standardization do not exist. And this is why you can hear quite often while discussing SMRs the desire of vendors to go towards a harmonization of requirements to ensure regulatory certainty. This is also linked to the question of recognition of another regulatory body assessment or license, whether it is feasible and on what basis, especially when two countries do not share the same regulation to assess a design, is still open, as currently there exists no mutual acceptance or approval of license. You have certainly noted that I have listed questions without answering them, and this is what makes this part of nuclear law exciting. It is currently being analyzed. The Regulators Forum will address some of those questions, specifically on regulatory oversight and sharing of information. Some legal gaps are being identified under consultancy meetings described by Miguel, and experience from different countries might help provide potential solution and way forward. But it is still an open discussion, and it is worth recognizing the challenges ahead of us. On this note, I am concluding our presentation. Thank you for your attention.
Thank you very much, both Miguel and Camille, for that very helpful and comprehensive overview of IAEA activities related to SMR regulation. For our second presentation, we will now shift focus to the industry level and let Helen take us through the Fermi Smr licensing study. Helen, please, the floor is yours.
Thank you so much, Denise, and thank you very much to the Centre for International Law at the University of Singapore for this opportunity. It's always my pleasure to participate in your initiatives. And thank you also to the IAEA for that excellent introduction, because you've actually covered a lot of the subject matter beautifully that I want to actually talk about today and link back a bit to the industry perspectives. So I want to talk about legal and regulatory solutions to facilitate SMR deployment. And I want to jump straight into some quotes from the nuclear industry, specifically the SMR industry. And the first one is that the term SMRs is not a description of a technology, it's a description of a business model. Now, I find this particularly helpful as a way to think about the SMR market when, if we look at it from a technology perspective, we see more than 70 plus different technologies, different designs, and it's quite hard to talk about that market in generic terms. But there is considerable alignment around the drivers of the business model. And if we can think about SMRs in this context from a business model perspective, I think we can actually talk about them as a category in a more generic sense. Now, this next quote is from Jacopo Bongiorno of MIT, and he, when speaking of factory-built microreactors, said, "This machine arrives on the site and just a few days later, you start getting your energy. So it's a product, not a project." And I just want to repeat those words. It's a product, not a project. And I love this quotation because I think we need to start moving away from the experience that we've had in the large reactor market, where every project has been unique and bespoke in multiple different ways. And we need to move towards seeing SMRs as commoditized products for deployment and not each one as an individual project. Now, the next quote is, I'm primarily concerned about the costs and risks of obtaining a license to construct an SMR in my country. Now, this was said by the CEO of a future SMR owner or operator, and it was actually by a future SMR owner operator in an embarking nuclear country. But I think this is a common sentiment expressed by vendors and owner entities all over the world. And I wanted to mention it because it highlights the regulatory and licensing risk that is huge, and the tremendous potential of regulatory and licensing processes to impact not only the commercialization of technologies, but also the schedules and budgets for SMR deployment. Now, my next two slides seek to link up the business case drivers for SMRs with certain success determinants that are focused on regulatory and licensing matters. And Camille did a particularly, as I said, fantastic job at identifying a lot of the regulatory and licensing issues that we need to solve to be able to deploy SMRs. And to take them back to the business case for SMRs, I think we can see that the fundamental drivers of the business case, whether that's about simpler, safer, more passive safety systems, different deployment models, or being able to develop a standardized SMR design, or indeed, as Camille talked about, being able to manufacture in one country for deployment, and maybe even go as far as fueling and commissioning in one country for deployment then in another. Whether we're talking about economics, whether we're talking about the financeability or the ability for SMRs to penetrate different markets and have more access to markets where large reactors might not have been able to go to certain reactors. All of these business case drivers are so very much dependent on the approach to regulation, the ability to solve regulatory issues, the ability to develop optimized licensing processes to see SMRs deployed and to see the business case objectives for SMRs being met. So I don't have time to go through all of the specific examples, but I think that you will appreciate, both from what Camille has said and also what I'm saying about linking this back to the business case for SMRs, that we need to come together as regulators and as industry to solve these regulatory issues, to develop ways to optimize the licensing process, and ultimately to reduce regulatory risk if we want to see SMRs successfully deployed around the world. Now, luckily, as we've heard, the good news is that a lot of work is being done, and I just commend my Iaea colleagues for all of the fantastic work that they have done and that they are doing in this space. The work is absolutely vitally important. But I think I want to give a little bit of a more somber, maybe pragmatic or practical message, which is, for a lot of the work that we're seeing being done, and that's not just done by the Iaea, of course, there's multiple different entities, government-driven entities and industry initiatives that are looking at this. But if we are reasonable and pragmatic about it, I think we would agree that some of these initiatives, like global or even regional regulatory harmonization or international design certification for SMRs, will not support the first intended wave of SMR export. And that's a crucial wave, because that could set up whether SMRs as a business case, as a business model, as technologies are going to be successful and are going to solve our future energy needs for our decarbonised world or not. So we need to get this first wave right. And I think we need to be focusing on achieving the long-term objectives, and they're important objectives, but also focusing on the here and now solutions. How do we get this first wave of not just the prototype plants and the first designs, not just how to get them licensed, but how to roll them out and how to export these technologies around the world. Now, there are some new perspectives, and I want to talk for a minute about the work of Fermi Energia. Fermi Energia is an Estonian company, a private company that seeks to be one of the first deployers of SMRs in Europe. Now, interestingly, the Estonian government has not yet decided to pursue nuclear energy, but earlier this year it did set up, in IAEA terminology, an EPO, or a committee, a government committee, to consider the prospect of nuclear energy in Estonia. Now, Fermi, as in its initial pre-feasibility work, has identified the significance of licensing on SMR viability. And it commissioned the Finnish utility Fortum in 2020 to do a study on the optimal approach to SMR licensing, with the starting point of a relatively blank canvas as currently exists in Estonia. And the output is a potential licensing model for obtaining a construction license for an SMR. And while the study specifically considers Estonia, it does aim to propose a model, and it has produced a model that can be accepted more broadly, both in embarking nuclear countries and also in established nuclear countries, and arguably for small and large reactors. Now, the report is extensive and the findings are many, and I've done my best to consolidate some of the key findings into this slide here. I just want to focus actually on two of the findings, and that is the two that are highlighted here, number 2 and number 3. So number 2, that licence applicants should seek maximum utilisation of an existing safety case or a safety analysis report prepared for a standard SMR design or a reference plant. And then finding number 2, that the licensing model adopted by the regulatory body should seek to achieve maximum utilisation of the safety assessment undertaken by an experienced foreign regulatory body for the standard design or the reference plant. Now, I'm thinking that most of the people on the webinar today will probably understand what a standard SMR design is. I just want to make sure that everyone understands what the reference plant concept is. And it's actually a concept that's been around for quite a while, and it is commonly utilised and has been utilised in large reactor projects where the construction contract for a new plant will reference an existing nuclear power plant, possibly operating, possibly under construction, and the contract will contain the requirement that the new plant is to have the same design and safety features, and sometimes even the same supply chain, as the reference plant. And the key point here is that the design is already licensed by an experienced regulatory body. And so the recommendation really coming out of these two findings of the study is that an optimized licensing process should be put in place that will build on the licensing and regulatory work that's been undertaken for a standard SMR design or a reference plant, and not be repeating that work from scratch over and over and over again. And that there is a responsible way to do this, which respects the exercise by the independent national regulator of independent decision making. And Ian will actually speak next about a recent example where an optimised licensing process was successfully and effectively employed, utilising both these concepts of maximum utilisation of the safety case of the reference plant, as well as the safety assessment undertaken by an experienced nuclear regulatory body. So having said, I want to actually just mention two other documents that are related to the work done by Fermi. And the first is the SMR Licensing Principles, which were prepared by Fermi's advisory group, which worked with us on the study. And you will probably recognise some faces on the left-hand side of my screen. And the principles generally follow the findings of the Fermi study, including supporting the two principles that I just outlined. And then there's also the Tallinn Declaration on the Future of SMR Licensing, where a number of companies in the nuclear industry, European companies in the nuclear industry, some of them existing companies, some of them intending to be future SMR companies, got together and again have generally endorsed the findings of the Fortum study, in particular around the two principles that I mentioned. Both of these documents are actually publicly available, so if you can't find them, I'm certainly happy to provide a copy to anyone. And here's the list of companies that signed the Tallinn Declaration and that supported the principles that I've just outlined. Now, Fermi has also engaged in outreach to various, including the International Atomic Energy Agency and then various important nuclear safety regulators around the world. And we've been engaged in discussions on how to actually take these principles forward in a practical manner. And we will continue those discussions. Now, a question that you might ask, having heard me articulate these principles and also say that the concept of the reference plant has been around before, it's been used before, and we know that regulators cooperate together and have shared information on safety assessments. So you might say, well, what's new about any of this? And I think the point that's new is that these principles in concept need to become accepted and standard practice for licensing SMRs globally. We cannot afford to treat every SMR deployment project as a project. We need to be moving towards developing SMRs as products, standardized products, and we need to be working on standardizing every facet of their deployment, which includes regulatory processes and licensing. So some conclusions on potential things that could be initiated early, things that could be done now to facilitate SMR deployment from a legal and regulatory perspective. Well, let's start with industry and then move to the regulators. So on industry side, of course, we need to be focused and encouraging the industry to be focused on the licensing and the construction of the first of a kind standard design and the demonstration projects as the priority. But simultaneously, we need vendors and licensees to be paying close attention to the ability to achieve the true nth of a kind future projects that will facilitate the economies of replication, which is so essential to the business case for SMRs. And this includes thinking about not just the next project in country, wherever that country is, but also the future export, and specifically the exportability of the safety case. On the regulators side, we need, of course, our experienced nuclear regulators to resolve these novel regulatory questions that are derived from the new designs and new deployment scenarios that we see for SMRs. We need to be thinking about developing harmonised regulatory regimes to, of course, facilitate SMR design standardisation and optimise licensing processes. But my message is we need immediate solutions, and we need to be focusing on immediate solutions as well as those longer-term goals. And some of those immediate solutions will include developing standard models for mutual recognition of safety assessments, as well as standard mechanisms of bilateral regulatory cooperation to facilitate that. Now, I think that there is a real opportunity for newcomer countries as well that are only considering deployment of SMRs to develop fit-for-purpose, optimised regulatory frameworks for SMRs without essentially some of the baggage that comes with some of the large reactor regulation. And then we also have an opportunity to see similarly situated newcomer countries, again, that are looking at developing SMR programs, to cooperate with each other in the development of their SMR regulatory frameworks, and in doing so, to develop harmonised markets, harmonised regulatory standards for deployment of standardised SMR designs. And that will obviously be of great benefit in the future. Thank you very much.
Thanks very much, Helen, for sharing this case study. It's very interesting to see how the findings from this study actually form the basis of the Tallinn Declaration. And in view of time's marching on now, I think we'll go straight on to the third and final presentation. We have Ian, who will share his thoughts on the lessons we can draw from the Baraka licensing experience. Ian, the floor is yours.
Thank you very much, Denise, for that introduction. And thank you also to the University of Singapore for the opportunity to collaborate and contribute to this seminar. It's a pleasure and a privilege. I'm going to address the question of licensing frameworks from the perspective of experience in licensing the first nuclear power plant in the UAE. And I see that really my preamble has all really been said. We've heard of SMRs as a business model, as a product with advantages which are seen as reducing financial risks, reducing costs, diversifying potential applications, and enhancing safety. But there are challenges with this business model, including the variety of designs, which I think at a technical level militate against standardization currently, new players, and the readiness in some cases of the technologies that are being offered. There's a particular challenge in international licensing of standard designs, And as Miguel, Helen, and others have referred to, various initiatives are underway to address some of these questions. One that hasn't been mentioned, I'll just put into the conversation, is the work that's taking place between here in Ottawa, the Canadian Nuclear Safety Commission, and the US Nuclear Regulatory Commission, incorporating on reviews of standardized, advanced reactor designs. But the focus of my presentation is to reflect on what we can learn and apply from past successes. And in this regard, I'm going to refer now to the Baraka plant. This is the timeline that the UEE achieved in deployment of its first nuclear power plant at Baraka, moving from left to right from 2008, the first manifestation of government intention with the publication of the nuclear policy, followed over the succeeding couple of years with development of legal and institutional frameworks within the country, the nuclear law and establishment of the regulatory body, application for a construction license in 2010, leading to first safety concrete in 2012, and then the operating license application in 2015, and finally commercial operation. The status of the facility as we speak today is Unit 1 is in commercial operation, delivering 100% power to the UEE grid. Unit 2 received its operating license from the federal authority, FANR, in March of this year and is in the early stages of nuclear commissioning. And Units 3 and 4 are in the final stages of construction and preparing for operation. And I'm going to walk you through the major milestones now in this timeline. So the UEE policy, you can, if you search on the internet, you will find a slim document entitled Policy of the United Arab Emirates on the Evaluation and Potential, now actual, development of peaceful nuclear energy. And this document sets out in visionary language 6 high-level goals for the program. Complete operational transparency, opening to the world to explain what the basis for the program and what is happening in the program. Pursuit of the highest standards of non-proliferation, safety and security. Close cooperation with the IAEA. Partnership with governments and firms of other responsible nations. And lastly, recognizing that the nuclear program is a long-term commitment in any country, managing the program on the basis of long-term sustainability. This document and these policy goals guided the subsequent program development and implementation. Just 18 months later, the next major plank was laid with the enactment of what is known as Federal Law by Decree number 6 of 2009, titled Concerning the Peaceful Uses of Nuclear Energy. This bill or statute sets out the legal framework for the conduct of nuclear activities in the state to ensure safety, security, and exclusively peaceful uses. It also establishes the Federal Authority for Nuclear Regulation as the independent regulator with responsibility for safety, security, and safeguards, and sets out the primary responsibilities of licensees for safety. There are other laws, obviously, that influence and affect the nuclear power plant within which it works, existing laws for environment, for security, and other such matters, but this is the main legal plank in the UEE's nuclear framework, legal framework. The UEE also worked to leverage international experience. The UEE has been a member state of the IAEA since 1976 and was a party to some of the relevant treaties. As the program came toward maturation, the UEE worked to adhere to all of the relevant international instruments for the 3 S's, the Convention on Nuclear Safety, the Convention on Physical Protection for Nuclear Materials, to name just a couple. The UEE also made and acknowledges the benefits it received from the use of IAEA services in 3 main areas: the use of IAEA safety standards and guidance, the participation in the technical cooperation program, which was aimed principally at building human capacity through various training initiatives, such as expert missions, scientific visits, and so on, that enabled staff to learn in other experienced nuclear countries, and also through a host of peer review and expert missions with an alphabet soup following of in-ear IRRS EPREV missions, through which the UEE was given a peer review and recommendations on what it needed to attend to in order to ensure the successful outcome of the program. And last but not least, the UEE worked hard to cooperate with other established national regulators. Also in 2009, still this is only 18 months after the policy was issued, the Emirates Nuclear Energy Corporation, a state corporation formed under Abu Dhabi law, or ENEC for short, announced the selection of a consortium led by Korea Electric Power Corporation. And the consortium was to design, build, and help to operate 4 APR 1400 nuclear power plant models. Now, this is a big plant in terms of output, but it has a business model that is akin to the business model that Helen has referred to for SMRs, in the sense that it is one of a series of standard designs. There was a reference plant previously licensed in Korea, and indeed earlier versions of this technology were licensed in the United States, and there are examples operating in the US. KEPCO is one of the world's largest nuclear energy businesses, with currently 23 reactors operating and 4 APR 1400s still under construction. And as part of the consortium came along as prime contractor, a joint venture between Hyundai and Samsung, who were an experienced nuclear constructor responsible for the work done in Korea. Now, FANR, in the background during this period, after its formation, and indeed before its formation, working unofficially, had worked rapidly to prioritize the development of regulations and guides according to the needs of the project, starting with the regulations on management systems, leadership and management for safety of the licensee, regulations for siting, design, and requirements for the construction license application based on the relevant Iaea documents. FANR also reached out to establish arrangements in cooperation with other national authorities for security, non-proliferation, emergency preparedness, among other matters. And it built a licensing system in consultation with stakeholders and the licensee, suitable to the UEE and the state of FANR's readiness, leveraging experience from Korea. This is a shot of a photo of the construction license. The two figures in the photo at the background are, on the left, Bill Travers, who was the first Director General of FANR, a very experienced American official, and on the right, Mohammed Al-Hamadi, who is still in post as the CEO of ENEC. But in the front is arranged one copy of the preliminary safety analysis report supporting the license application for construction. And it illustrates the magnitude of these applications and the documents that are required. And review of an application such as this is a potentially complex, time-consuming process that involves tens of thousands of person hours of work, a lot of money, and quite a bit of time. And that's when things are going well. And so FANR worked quite hard to optimize the review of this document. And key to our licensing process was collaboration with the regulatory body in Korea. FANR formed strong relationships with the Korean authorities based on intergovernmental agreement and MOUs, which provided for exchanges of information on the topics listed, as well as support for vendor inspection and UEE staff training and development. And we used a reference plant licensing approach, the reference plant being located in Korea, which had previously been licensed in Korea, as you recall. The safety report identified departures from the reference plant, and we used that information to key FANR's findings on the Korean assessment, the safety assessment, where applicable, where the design was compatible. And I assert that this had two main benefits. First of all, enhanced safety, because we were working with other experts who were familiar with the technology, but it also facilitated the speedy progress of the review. FANR conducted its own review wherever the design differed from that license in Korea, where there was new operating experience since other regulatory bodies' approval, And I don't have time to dwell on this, but one word will suffice, and that word is Fukushima, which caused a significant amount of additional work to safely resolve the questions arising. And we also reviewed topics that our experts consider risk significant, for example, the management of severe accidents. And our written review plan identified the review category for each topic. And I just note in passing that there are some parallels in FANR's approach with the World Nuclear Association licensing model, which was published around the same time as I was working in Abu Dhabi. So coming to a conclusion, in my view, and this is up for discussion, others might have a different view, but in my view, some of the ingredients to the UAE's success in delivering this program included a strong national position and rationale for nuclear energy in the policy, leadership by the government and timely actions to establish the legal and institutional framework, the selection of an established technology with a reference plant, having a mature supply chain and experienced constructor behind it. I remember meeting actually some Korean engineers on site in Baraka, and they had binders of photographs from the reference plants and say, this is what it's going to look like in 3 months' time. They weren't on a quest, they knew exactly what they were going to be doing. FANR and the operator were successful in acquiring needed human resources and skills. But key in particular were the cooperative relationships between regulators and the host and vendor country, the use of the vendor country standards and guidance to the extent practicable, and mutual recognition of regulatory safety assessments and licensing. How far can we go with this? Well, I see a few opportunities, but also some limits. Clearly, designs, safety assessments are not linked to a particular location and are, in my view, it's possible to transfer these, to standardize these, to recognize these. This may be up for debate. Is it a product or a project? There's certainly some areas, I think, in any nuclear facility that are inherently more localized. The local planning and consultation processes that lead to a decision to go ahead. The site, as in the UAE, there was nothing we could learn from studying the Korean site. We examined the site ab initio, and the environmental assessment was also conducted in Abu Dhabi. And to a degree, the operating organization and human resources are also local, although I think that possibly the operating organization can use procedures from a standardized approach, but it's very definitely an organization in each locality operating the facility. And lastly, as an experienced regulator, I would say that regulatory cooperation is, I see no downside to regulatory cooperation, but in the end, I believe that the host country regulator is ultimately accountable for its decisions. In the legal frameworks under which we operate, it's not really possible for, I never felt it was possible for me to say, it's not my decision, we're doing this because the Koreans advised us. No, this was always in the UAE, the regulator's responsibility. And I will end there. Thank you very much. I've included in my last slide, for those who are following and see some links to additional information, particularly on the Iaea and reports that have recently been produced on case studies, but I'll leave those for reference and further reading. Thank you very much for your attention.
Thank you very much, Ian, for that presentation and for the reminder that experiences from licensing traditional large reactors in respect of newcomer countries also holds insights into the issue under consideration today. So turning now to Q&A, thank you to participants who have sent in their questions. We will certainly do our best to answer as many of these within the time that we have remaining. I'll start first with a question for Miguel, if I may, and this is in respect of the SMR Regulators Forum. The question is simply, how are the priorities of this forum established? Miguel.
Thank you for the question. Well, precisely at the end of last year, the forum held at least 2 meetings or more to discuss the areas of work for the next phase 3, which started at the onset of 2021. This this is a very lengthy process, and all of the members have equal opportunity to offer their areas of concern, in which they would really appreciate the common grounds shared among all of the members in order to work together on those issues. So basically there is a pool of potential topics proposed by all of the participants of the forum, not only members of the steering committee, and these are prioritized first within the working groups, and they are in many cases a continuation of the previous work done by the working groups. And then these are discussed collectively among all of the members, including the members of the steering committee, which in the end makes the decision on the topics of discussion. And effectively for the phase 3, the discussions circulated around the recognition of work by other member states. What are the concerns related to safeguards or security of the this novel design that will challenge the existing practices, and what is the supply chain how this new supply chain, and I like to emphasize what statement made by Helen on the maturity of the supply chain. The forum believes that there will be lots of new players of the supply chain that did not exist before, or they were not part of the nuclear community, and they will have some things to learn, and they will have, of course, many good contributions brought out by many other industries. And this needed to be considered. As you know, one of the concerns of the regulators in general is about nuclear safety of all the chains, starting with the supply chain all the way to the operator, and how this new set of contributors or participants in the projects will bring their own state of mind to this process.
Thank you. We have a comment here, and I read it. I note that the private sector seems to be suggesting that we should not reinvent the wheel, and we can shorten the time for SMRs to come online by using successful designs and safety assessments. Does the Iaea agree with this approach? And are there risks because different countries have different unique circumstances? Miguel or Camille first, and then Helen, you and Ian can jump in as well after.
Yeah, this is a concern that the regulators always discuss about. The function of the regulators is not to stall the development of new technology or to stall the development of an industry. The role of the regulator is to ensure that the safety of the population and the workers and the environment is sufficiently good and reasonable, and but they have to bring to the picture some kind of independent view. I mean, we understand the economic interest and the challenges of the climate issues, and everything is considered by the regulator, but first and foremost is the safety of the workers, the population, and the environment, what is of concern of the regulators. As I said, this is a topic is continuously considered, but there is also a big baggage brought by the regulators to the table, and they have their own legal jurisdiction. They have their own legal duties to are accountable to their own countries, and this cannot be thrown away and say, okay, we are all going international now. It's going to be a lengthy process. That is why the forum, instead of starting working about harmonization and having common requirements for every single country, we talked about collaboration and the main topic of discussion is the recognition of reviews of other regulators instead of starting from scratch. I don't know whether you, Camille, would like to to add something to this from the agency perspective?
I think you were quite cover it all, and you mentioned that the reasons behind those differences in regulation is they stem from constitutional, general legal frameworks, legal traditions, cultural and social norms. So, yeah, the challenges are here, and it will be a significant long-term and complex challenges to deal with.
And if
Helen?
I may, yeah, thanks, Denise. If I may just add a comment, which is certainly that from Fermi's perspective and from the industry statements that I've heard on this subject, there is no intent to compromise on the fundamental safety principle that is, you know, the national sovereign regulator makes its independent decisions on behalf of the country, and that as a principle has to remain. But my belief is that is not necessarily in conflict with the concept that the National Nuclear Regulatory Body, in exercising its independent decision-making, could undertake certain steps like verifying the adequacy of the regulatory basis used in their country of origin, verifying the safety assessment, of course, of the process that was carried out in the country of origin by the country of origin regulator, applying a graded approach to the review of the safety assessment that was undertaken by that national regulator, and prioritising, and this is drawn from Ian's comments, prioritising those things that are of high safety significance and those fundamental departures from the reference plant due to perhaps site-specific conditions or indeed differing regulatory requirements. All of that, of course, needs to take place and feed into an independent national regulatory decision by the host country regulator. And of course, as Ian said, the host country regulator also needs to review the licensee to be sure that it has the requisite capabilities and competence to act as the licensee of a construction project and then the deployment and operation of an SMR.
Thanks very much, Helen. Ian, is there something you'd like to add?
Yeah, I agree with what my colleagues have just mentioned. The question was, or I understood the question was that the private sector would like to see regulators standardizing, harmonizing. And I agree with that. I also would say that I think that the regulatory question is not the only issue in terms of bringing SMRs to market. To my ears, it seems to be characterized often as a regulatory issue. But I think it's very much on the proponents to develop the necessary technological background, the safety case, and to present this to regulators in the form that regulators are able to accept. There are a lot of small companies offering innovative designs, but I refer to the idea of technology readiness levels. A lot of these designs still have a lot of work to do in terms of engineering and regulatory work to get to a point where they have a safety case and they're ready to be licensed. And I see also a sort of winner-takes-all approach. Once a plant is licensed, once there's a prototype operating, once the safety case has been accepted by a regulatory body that has credibility and a reputation around the world, I think that will become a very strong advantage for marketing and for deployment of that particular design, that particular safety case in other countries around the world. I see a model somewhat similar to aviation in the sense that it's so costly to bring new designs to market that once one is successful, it will break through and it will become a standard, I think. Several thoughts there.
If I may add a little bit, actually, I think that Ian touched upon one of the critical points for regulators, and this is the construction and approval of the first of a kind. I mean, every country or every regulator in the world will be much more confident if they were to the one that the host country wants to buy and has been properly licensed and has proven to be safely operating for a considerable period of time. If that happens, it's a much easier work for every regulator. Now, I would also like to touch upon one point raised by Helen, and I agree with her that there is lots of simplification to be made in not to repeat and not to start from scratch on things that are not necessary to do so and focus on the main safety areas and all that. And I also like to emphasize the UAE examples in which they did an exemplary work in terms of developing the program, developing the regulators, developing the entire project in a really admirable way. But I will also challenge anybody to tell me what other countries have those means to go in that way. We've seen power plants installed in countries or being installed in countries that do not have those means. And the developing of the competences of the regulator is very challenging, and the developing of the industrial base is also very challenging. So the UAE example is extremely good, but it's not very easy to reproduce.
Okay, thank you. I have a question now on Camille's part of the IAEA presentation. And the question reads, to what extent has the IAEA and IMO exchanged views on the applicability of IMO instruments as regards floating nuclear power plants? Camille, you mentioned SOLAS, the IMDG code, etc. Would you care to comment, Camille?
Yes, thank you, Denise. So I mentioned it as part of my comments on the transport reg, and it's true that the IAEA now is currently considering the applicability of those transport reg, and it's my colleagues from the division of transport safety that is doing so. And in doing so, of course, at one point they will also have to discuss certainly with IMO and see the consequences on the IMDG code. And now, having said that, it's up to the IMO. It's not up to the IAEA to determine whether the SOLAS Convention, the United Nations Convention on the Law of the Seas, etc., will apply to floating nuclear power plants. So I think, yeah, it's out of my scope of.
Okay, thank you, Camille. Moving now the focus to newcomer countries. I have a question here on, is there any advice you would provide newcomer regulators who may not necessarily be members of the SMR Regulators Forum, but are interested in building capability and capacity in this area? What should they do? Miguel, maybe we'll start with you.
Yes, well, the agency has numerous programs that will help not only to develop the industrial base through our nuclear energy department, but also to develop the nuclear safety and legal infrastructure. And they should contact us, and perhaps through the technical cooperation program, there are many special activities on training, on expert missions, and of which Ian has taken part of in several occasions to help them to do this in much more efficient. And I believe the focus of these support activities is to avoid these countries to go through the lengthy process on doing it on your own and committing sometimes errors that other countries have committed, and really come up with a quick solution before the problem even arises. So I would say contact the agency, if you're active in your technical cooperation program, either on the framework side, regulatory framework side, or on the technology side, and try to get all of the means of support that the agency support, which are quite a few.
Helen, a related point you brought up in your presentation, that there's opportunity for similarly situated newcomer countries, I think your slide said, to cooperate in the development of their regulatory frameworks. Would you just like to expand on that in the context of this question?
Absolutely, Denise. Thank you very much. So my answer generally would be, I guess, two things. One, early strategic bilateral cooperation with the established country regulators would be something that I think you could do straight away. And then, thank you, Denise. The other point that I would make is to think about linking up with other countries that might be looking at deploying SMRs and only SMRs, and look at how standard practices and a common regulatory basis, so harmonizing those regulations, of course drawing on Iaea safety standards, but harmonizing with those other similarly situated countries will be very, very useful, because then you're effectively creating a harmonized set of countries and a harmonized set of markets with the same regulations, which will facilitate the ability of vendors to develop their standardized designs, get them licensed, and get them deployed in those countries.
Ian, thank you, Helen. Ian, I'm just wondering if you have anything to add. I think Miguel's point was well taken when he made the comments about the Baraka situation and how that's quite unique, but to the extent that there are lessons there that you think would equally apply to newcomer countries generally. Would you like to chime in?
Yes, absolutely, Denise. Thank you very much. And I accept what Miguel had said, that the UAE has some unique characteristics as a country that enabled its fast start. But I pointed out several success factors which I think others could adopt. The government played a really strong role in terms of policy clarity and taking the necessary action in a timely way to pass laws. I think that is given to most states to be able to do if they have the political will. And I also think that one of the things the UAE did very well was building human capacity among nationals, which is the focus, as Miguel has said, of the technical cooperation program with the UAE. But domestic activities included things like setting up in Khalifa University, one of the local universities, a master's program to develop a cadre of people who have had the necessary technical and legal skills to take over from expat people such as myself, and to maintain to keep the regulator going on a sustainable basis. Now, nearly 65% of the employee group at FANR are national Emiratis who joined since the program started up. And building that local capacity is key to putting the program in long-term, managing the program for long-term sustainability. And it takes longer to make a trained reactor operator than it does to make a steam generator. And human resources are the long pole in the tent.
Thank you, Ian. I think we'll take one last question before we start wrapping up today's webinar. And this is a question for Camille. I am aware that the IMPRO Dialogue Forum has in the past done work on legal and regulatory issues. Just curious to know, how is this work being coordinated with the work of the SMR Regulators Forum? Camille.
Thank you, Denise. So indeed, the INPRO, so the International Project on Innovative Nuclear Reactors and Fuel Cycles, have published in 2013 for the first time legal and institutional issues of transportable nuclear power plants. And now they are working since a few years on an international project on innovative nuclear reactors and fuel cycles. And they will publish soon a case study for the deployment of a factory-fueled SMRs. And here you can see it's, so the first one and the second one is based on case studies, and they encompass parts which are looking at the legal and regulatory framework indeed. And the SMRs Regulator Forum has always taken into account the different documents published by the agency, but also by other groups such as INPRO, and has a basis for their consideration. So now that they are starting to work on potential legal challenges, they will of course take into account such reports, and noting that it's specific to some design, and it's limited in its scope. So yeah, I think Miguel can add to it, but the SMRs Regulator Forum is generally basing their work on already existing documents and safety standards and publication, not only the Iaea ones, but overall, which are concerning small modular reactors.
Yeah, Camille is right in that the forum members look at all of the existing universe of standards and documents, and certainly they are aware of the work of INPRO. Now, this was not one of the high priority areas of the first 6 years of work of the forum. The members considered there were other areas that needed more prompt attention by the members. Now, in the third phase, as pointed out in one of our slides, we mentioned that the legal constraints and legal challenges is one of the areas that the forum will look at. And among the legal challenges, when you talk about transportable nuclear power plants, so factory-fueled reactors, and what challenges they arise from those activities that have not been tested in the past, and where we know that all of the international framework is not yet up to snuff to cover.
Thanks, Miguel. We're going to start wrapping up today's discussion, so we might overrun by just a little bit for another 5 to 10 minutes, if I may. As we're nearing the end of our time, I'd like to just take this opportunity to invite our panelists to very, very briefly share their thoughts from today's discussion. It's a rich topic with lots of opportunity, I think, still to develop this conversation. It is clear that a lot of work has been done and continues to be done at the international, multilateral, bilateral, national, many levels across multiple stakeholders. We are making progress. I think that's one of the messages. But possibly not quickly enough in terms of reaching a consensus on a clear strategy pathway forwards. So the question that I have is, in wrapping up the seminar, I think it'll be really nice to just hear your views on what you think might be some of the steps that the community can take collectively going forwards. They don't have to be big steps, but they could be small steps to try and build on the work that's been done to date and to possibly try and move things along more quickly. So just brief comments. We'll just go around. Maybe I'll start with you, Helen, if I may.
Denise. Yes, of course. Thank you. So I don't want to say I have a pessimistic perspective, because that's not true, but I hope I have a realistic perspective, and that is that while there are so many benefits to be gained from international harmonization and international consensus, that also takes time. It takes time to build that consensus, and of course when you get it, it tends to be established at a relatively high level. So I think my key message is that please, international community, continue to work and provide those valuable international consensus that we need. But in the interim, I think we all need to be thinking about the here and now solutions to support the first wave of SMR deployments. And I think in that context that I hope that we will see similarly situated or like-minded newcomer regulatory bodies getting together and looking to harmonise their SMR regulations. And I also think that maybe some of the most impactful work that we will see done in this space will be around specific deployment scenarios. So, for example, where you might have the new regulator in Estonia working with the US NRC and developing a methodology through which the Estonian regulator can review, can verify, can get comfortable with accepting and utilising as much of that safety assessment work that the US NRC has done to support a licensing process in Estonia.
Thank you, Helen. Ian?
Yes, I'd like to build on what Helen said. Thank you. I also feel myself hopeful, let's say, but also conscious of the various barriers and obstacles that need to be overcome to deploy the SMR business model. And I very much agree with Helen's point of view that in the long term, international harmonization is necessary, extremely desirable, but it's going to be some time to grapple with that and get it all aligned. And that in the short term, I do believe that bilateral, multilateral cooperation between host states and country vendor states offers a more immediate prospect of deployment of the first wave. And I think that working on procedures and cooperative agreements whereby a host state regulator could take advantage of, let's say, an existing CFK, such as the design certification issued by the US NRC, would be a fruitful first step to pick out, as Fanner did, how it might use an existing safety assessment and where it needs to do work on its own and what that work needs to be. I think that would be a very practical near-term objective to clarify.
Thank you, Ian. Miguel?
Yeah, I fully endorse what the two previous speakers have said. I mean, I believe that there is an international willingness to cooperate and to make things more effective and more efficient. There is no need to reinvent wheels. There is no need to redo work that others have done. Nonetheless, there is a duty especially by regulators that need to be fulfilled, and there is a certain competency level that is required, and this takes many years to achieve. It requires lots of effort and commitment, as Ian said, from the policy of the country, have looking and pushing in one direction for an extensive period of time. So they prepare their people, they give them tools, and they get ready for the time. As intermediate steps, bilateral cooperation works absolutely, but the preferred way would be multilateral cooperation, because there might be, although there might not be ill intention, there will be this what we call the capture thinking, or the thinking of small groups that they are all pulling the same direction, forgetting some factors. And that's why the more people involved in the decision, the better. And that's why myself, I would favor the multilateral collaboration. Now, picking up on the design certification that Ian mentioned, the US design certification, that would be a very good step. But as you know, Ian, mature regulators will spend probably the same effort to review the certified design as they would use to review a non-certified design. So it has its limited factors depending on the circumstances, but this is certainly could be a very good way to move forward for new embarking countries that really are building their framework. They are starting from scratch, and there are lots of good lessons to be learned from countries with lots of experience and lots of maturity. Thank you.
Thank you, Miguel. And finally, Camille?
Thanks, Denise. I think even though we could have lively discussion here, we all align in the conclusion. The harmonization is a step away from us, and it represents strong challenges both from the legal, legislative, and regulatory framework. But steps are taken towards also cooperation, potential mutual recognition, and these steps and this work performed by the SMRs Regulator Forum on mutual recognition will be enlightening, I think, for the future, knowing that we shall preserve the independence and ensure that the regulatory readiness of the newcomers regulators. So, yeah, those steps toward cooperation are the small steps forward.
Thank you. Thank you, everyone, for all your comments and thoughts. That just leaves me now to say a very big thank you to all our panelists for the very illuminating discussion we've had today. I have certainly learned a lot, and I look forward to seeing where this conversation will go. To our audience, thank you for enriching today's discussion with your questions. I very much hope that you've enjoyed the discussion as well. So thank you, everyone, and enjoy the rest of your day.
Thank you, Denise.
Thank you very much for attending the webinar today. If you're interested to find out more about the work of the CIL Nuclear Law and Policy team, as well as information on nuclear power-related developments, do follow our dedicated Twitter account at CIL_nuclear. In addition, our podcast series, Nuclear Matters at CIL, is available on the CIL website. This series seeks to share research and contribute to capacity building within the Southeast Asia region on nuclear law and policy issues of international importance and regional relevance. Have a great day, everyone.